Welcome to my world, the world of a medical laboratory scientist. Health is wealth, knowledge is power. Today's topic has to do with antibiotic versus disinfectant ineffectiveness. My effort today is to go back to the genesis itself of the disinfectants. Disinfectants have been known, very many, but the problem is how to get something that will not affect the internal. And that is one of the reasons why when Paul Hellish discovered Salvarsan, it was really heralded as a magic bullet before penicillin came. Now, we are now looking at these disinfectants that we even do use, like we are using them on human surfaces. Alcohol, for example, ethyl alcohol is a very strong disinfectant, but you can use it on human skin to really disinfect that area, acting more like something that is acceptable to the body. At 65% or 70%, it is a very strong disinfectant. But you cannot use the same wisdom to now take it in, saying you want to destroy the microorganism in the internal organs, the internal environment. So that is where we come to have antibiotics. And antibiotics ineffectiveness is now becoming more obvious. And disinfectants in themselves are also ineffective, but less ineffective against microorganisms. So today's effort is geared towards showing this ineffectiveness in the two groups, antibiotics and disinfectant. And like I always say, if you like my presentations, press the like button, subscribe, and let's move on into the slide session where I shall expose all the facts and figures. The outline: objective introduction, reasons for antibiotics ineffectiveness, reason for disinfectant ineffectiveness, lab diagnosis, progress made so far, prevention and recommendation. That will be all for this video recording. The objective: to display the different classes of antibiotics rate of losing their effectiveness and juxtapose it to the limited number of disinfectants available in order to make an inference and explain how antibiotics could retain their effectiveness for a relative longer period. The introduction: we must start by recognizing that disinfectants like alcohol, copper, sulfur, salt, and mild organic acid phenols have been in existence for at least 3,000 years. These chemicals were made mild in order to be used to kill microorganisms on living tissues, called antiseptics. The discovery of penicillin by Alexander Fleming in 1928 marked the beginning of the antibiotics era. The antibiotic really also displays the penicillin. They displays the Salvarsan, the phenolic carbolic compound that Paul Ehrlich really produced around that time, and even it was vilified because the effect of Salvarsan, the side effect of Salvarsan was becoming even a problem, and penicillin was easily very acceptable to the human body, yet it was doing the effective work of destroying microorganisms. There are several classes of antibiotics broadly categorized based on their chemical structure and mechanism of action, including penicillin. Yeah, the penicillins are so many because of these beta-lactam production by bacteria that makes them ineffective. So you have the list endless. All these are penicillin that has been changed by these semi-synthetic, the side chains are been added to become a little bit more resistant to beta-lactamase producing bacteria. So the names are methicillin, oxacillin, cloxacillin, dicloxacillin, neficillin, ampicillin, amoxicillin, carbanicillin. This table shows how they are resistant to acid and penicillinase. Penicillin G, you can see it very poorly resistant, but you have the methicillin that shows 700% resistant to penicillinase of the bacteria. This table shows the reason for the side chains of all these penicillin semi-synthetic antibiotics. It's showing their resistance to acid, the resistance to penicillinase, and their antibacterial organization, that is the spectrum, widening the spectrum of activity. Just like the penicillin, the cephalosporins are also having the same side chains attachment. You can see the various type of cephalosporin, cephalothene. Up till now, you still have things like cinnate and all the cephalosporins. Yes, the sulfonamides were also improved upon, and you find them having more semi-synthetic ones. Sulfonamide in itself is like chemotherapy. Sulfadiazine, sulfamerazine, and so on and so forth are the additional, like sulfaxazole, when they have additional side chains to the existing ring, make it more effective against bacteria. Now let's look at the ineffectiveness reason for antibiotics. Number 1, degree of susceptibility of the invading microorganism. This is often expressed quantitatively as the lowest concentration of drug that inhibits the growth of a given strain, and that is usually gotten in the laboratory evaluation. There is also the concentration of drug obtained at the site of infection. You want to know whether the drug itself can penetrate to the area that the infection is located, whether it is located in the brain, the bones. So you can imagine these areas are very difficult to penetrate. The location of infection too. Infection that are on the surface, the skin, is very easy to treat, but we also have pathophysiological state of the patient. If the patient is immunocompromised, for example, a diabetic patient, you find that the blood may be rich in those substances that will even boost the growth, and this may help the microorganism to multiply and even become septicemic, first bacteremic and septicemic. The natural history of the infection, the nature and severity of the infection, application of other supportive therapeutic measure, prompt incision and drainage of the abscesses. Where there is a serious inflammatory reaction, you have pus and all these things, the drug cannot penetrate to those areas. So the abscesses has to be drained before these drugs can penetrate and really kill the microorganisms that is prompting that reaction, the defense mechanism reaction. Microorganisms themselves are very dynamic. So microorganisms on their own could inactivate antibiotics. And that is one, by natural evolution and genetic changes, where there is mutation. Some mutation allow bacteria to survive in the presence of antibiotics, while others might lead to their growth despite antibiotic exposure. Because the antibiotic is selective in a way, it's not a broad spectrum. It allows some of these organisms that are not that are not sensitive to it to now multiply more, suppressing or killing the growth of those ones that are sensitive. There is also the gene transfer, like from in plasmid. The bacteria could acquire resistant gene from other bacteria, and then they transform by even conjugation, transduction, and transformation, where genetic material is exchanged between bacteria. There is also overuse and misuse of drug. When you overuse, you are
just using it for anyhow, you create unnecessary antimicrobial resistance through that way. And misuse, when you misuse antibiotics, taking incomplete courses or using them in inappropriate setting also contribute to the development of resistance. For example, using antibiotic in animal agriculture to promote growth allows resistant bacteria to thrive in animals, which can then be transferred to humans. Now, the third is selective pressure. Antibiotics act as a selective pressure as well by favoring, because when you use narrow spectrum, as like I earlier even explained, it propagates the resistant strain to grow more, because those ones that are not sensitive will not die and they multiply more, suppressing the growth of further the growth of the susceptible one. There is also the mechanisms of resistance that where the target sites, the molecule of that site that the antibacterial drug or whatever would attach to is now being modified by this bacteria, so that there is no way for that drug to be able to act on the bacteria. The drug efflux, other bacteria evolve mechanism to pump antibiotic out of their cells directly. Enzyme inactivation, we talk of beta-lactamase. Some bacteria can develop enzymes that inactivate antibiotics, rendering them ineffective. Then the one most dangerous as well is the biofilm. Bacteria create that biofilm. Bacteria in biofilm communities of cells encased in a protective matrix, so the antibiotic cannot penetrate, can also exhibit higher resistance to antibiotics. Now let's go into the ineffectiveness reason for disinfectants. With disinfectants, the bacteria don't really have much dynamics in against disinfectant, but the way we probably handle disinfectants or how we use them are very important. So number one is improper use according to manufacturers. The directive or instruction given on their leaflet is very important to follow. Then the high pH or the wrong pH. If you are trying to attack bacteria that would want that lives in acidic and you are using a disinfectant that does not work in the acidic environment, that's another point. Insufficient contact time. Disinfectant really works in the liquid form when it's able to be soaked well into this material or things that you want to disinfect. The moment it dries up, the effect of the disinfectant is not felt anymore. So that is what is called the contact time. So you must leave enough time for the disinfectant to penetrate and destroy. Too low concentration. When you over dilute the disinfectant, that's another one. Then organic matters, those also prevent the disinfectant from penetrating. Organic matter like blood and co, they do not allow this disinfectant to really get to reach the site of the bacteria or microorganism you want to destroy. Then the sixth, the expiry date of the disinfectant. Then we have 7, temperature. Relative humidity for gaseous disinfectant, for example, the formaldehyde, and there is ethyl oxide and others that are gaseous. If the humidity is poor, it may not be able to penetrate all the areas. Duration of exposure is like the one I'd explained as insufficient contact time. Biofilm, I've explained it earlier. So where the bacteria cover itself, one effort recorded by microbes against disinfectant. This is where you can say the dynamism of the microorganism itself. They've now formed a kind of biofilm that prevents the penetration of, probably like we talk about, organic matters, not allowing it to fit. Then the innate resistance by forming spores. These are also what bacteria dynamism talks about. They are by their nature, some form spores that these disinfectants cannot penetrate. But there are some disinfectants that are sporocidal, and we shall mention them. Microbacteria have a waxy cell wall that prevent disinfectant entry. The same thing you have Pseudomonas aeruginosa also naturally shows some innate resistance. But lipid envelope microorganisms are easily susceptible to disinfectants. Yes, laboratory diagnosis. The laboratory is very important in when you are talking of effectiveness of antibiotic or disinfectant. This susceptibility testing is usually done by the agar diffusion method. There are so many methods, but the commonest is agar diffusion, where the diameter of the zone of emission is measured and compared with standards to report sensitive or resistant to the antibiotic being checked or being used against the microorganism. For in the case of disinfectant, the dish containing the material for disinfection and the disinfectant is sampled after a relative while. It could be a day or two. But when it's longer, well, it depends on the quantity of contaminants. To know if the sample collected when streaked on a plate will grow any organism if incubated overnight, showing how effective the disinfectant is. So the disinfectant in itself is informative because when it starts changing color as well as smell, you can also sense that the bacteria are overcoming the disinfectants, or that the disinfectant is no more effective. That's the right word, because the effectiveness have been used. Because when you change the fluid, the disinfectants will still start killing all these bacteria. Now to progress made so far. So many efforts are being made in the direction of exploiting the side chain of many antibiotics, which I had earlier shown during the introduction, which helps in producing many semi-synthetic class of antibiotics like the penicillin as shown in the table earlier. Also, we have for the cephalosporin, the tetracycline, the aminoglycoside. We also have imipenem, is a synthetic beta-lactam antibiotic belonging to the carbapenem chemical class. There is also the meropenem and hartronam. These are all improvement on the imipenem. And all these efforts has been met with resistance from bacteria and other microorganisms that are making it impossible for this improvement, this with creation of many synthetic antibiotics too. So every effort has met with antimicrobial resistance based on factors earlier highlighted. But there is hope anyway in the latest discovery of penibacillus, found to produce a new substance that attacks antibiotic-resistant bacteria. It is called lariocidin. It is not susceptible to many of the mechanisms that make disease-causing bacteria resistant to the available antibiotic, the researcher told Fox News this just of recent. However, unlike the fear of antimicrobial resistance, AMR entertained for antibiotic, very little fear of disinfectant resistance is being entertained, especially with the fact that those microorganisms that have lipid envelopes remain highly susceptible to disinfectant. That is not to say that some microorganisms are generally resistant to some type of disinfectant used as antiseptics. It is necessary to state that glutaraldehyde has gained wide acceptance too as a high-level disinfectant and chemical sterilant. It is sporicidal when activated, that is made alkaline at pH 7.5 to 8.5. Peracetic acid is also sporicidal with special advantage of remaining effective in the presence of organic matter. So these are basically improvements on the weaknesses where other disinfectants are weak. You can use these ones in their place. Finally, recommendation. The recommendation shall look at the objective effort to how bacteria can retain their effectiveness for a longer period. So it is geared towards that little advice. Any antibiotics ineffectiveness is a serious matter because without effective antibiotic, the complication common with surgical operation will assume an alarming proportion because surgical wounds may not heal. However, in order to minimize these threats, all the highlighted overuse or misuse of antibiotic must be curbed. In that way, we allow this antibiotic to last longer, to be relatively more effective for a very long period. Sanitation is another point. Sanitation must be our watchword, especially the acronym WASH. Water, washing of hands, sanitation and hygiene. With that way, when our environments are really subdued, free from these large contaminants, these bacteria that really have their way to our system, then we may not be abusing or overusing antibiotics. More research, however, into how disinfectants that has remain immutable all these years should be studied and applied to creating another drug like Salvarsan. Though with Paul Ehrlich's experience, it was later vilified when penicillin became more effective and having less side effect because Salvarsan was having more side effect and it was disused. Not that it was in itself not effective. So if we can in any way move towards the idea of Paul Ehrlich at making Salvarsan and using it to also make other disinfectants acceptable internally with less side effects, which is the problem with majority of these other chemotherapy that are from chemical compounds. Antibiotics are more acceptable in internal environment because they are more organic or more or less life form than the chemicals that act on the cells of the body. So I will advise that more videos are on, counting on 174. So watch more of my videos and click like as usual.